Welcome. In this video, we are going to talk about translated or shifted hyperbolas. In the video before this, we looked at hyperbolas that were centered only at the origin. And the main difference here is we're going to add that h and k value. So we're going to say x minus h squared over a squared. And then we've got y minus k squared over b squared. That would be equal to 1. So you'll notice, since we have x squared minus y squared, that this is a horizontal hyperbola, horizontal transverse axis, which means I have two hyperbolas opening to the left and right. Of course, the order, if we had y squared minus x squared, that would make it a vertical hyperbola. The one thing we want to make sure we pay attention to, and especially because we're used to putting x first and y second, is that h is always with x and y is always with k. And depending on that order, the k could show up first and the h could show up second. And by that, I mean we could have y squared minus x squared. So that would be y minus k, quantity squared, over a squared, minus x minus h, quantity squared, over b squared, equals 1. So we might look at this and go, okay, well, there's my center, h, k. I've seen that mistake happen. So remember, h is always with x, the x coordinate of my center, and k is always with y. So now, instead of me writing out all of the details, because we're pretty familiar with these patterns at this point, I'm going to pull in a nice picture for us. Here we have a standard equation with a hyperbola centered at hk. If we have a horizontal transverse axis, that means this axis, this horizontal, is transverse. It's going across both of my hyperbolas. And you'll notice my center here is at hk. My vertices, I've got two vertices. How many units away from the center are my vertices? Let me look at this. This point is a units away, and that point is a units away. The vertices are going to be plus or minus a. And you notice that plus or minus a is attached to the x coordinate, or h. All right, the foci are also in there. The foci are c units to the left and right. So that's h minus c and h plus c for those two foci. And remember, c squared is always a squared plus b squared, plus. The hyperbola has a minus in the standard form. The c equation has a plus, and we flip-flop that for ellipses. Okay, so we also use basically a point slope version in order to write the equations of these asymptotes. And if you think about a point slope line, we say y minus y sub 1 equals m times x minus x sub 1. So the x sub 1 and y sub 1, those are the h and k values. And then that slope is b over a. Remember, slope is rise over run. B is under y, change in y. A is under x, change in x. Same thing for a vertical transverse axis. You're only going to see that difference is that when I mark the changes in all these points, they're going to be a change in the y values. So A gives us a change for our vertices, plus A and minus A, plus A to the k, and then minus A from the k value. That shifts us up and down off the center. And the foci, we've got C, plus C units off the center and minus C units off the center for those 2 points. And of course, then the asymptotes. The only difference here when we talk about that slope is A over B. Remember, slope is rise over run, change in Y over change in X. What's the number under Y? A. What's the number under X? B. In this case, our ratio for the asymptotes, if it is a vertical transverse axis would be A over B. So now that we've looked at all of that and we have a good understanding, I think it would be important for us to look at an example. In this example, we're going to identify the conic, hint, we know it's a hyperbola, and its orientation, and then we'll state the pertinent attributes to create a graph. Looking at what we have here, we have 4y squared minus x squared. Is this a parabola? The answer is no, not a parabola because we have both x squared and y squared. And then we know, since I have 4y squared minus xy squared, because these two terms have different signs, it's not a circle or an ellipse. Therefore, looking at both that x squared and y squared term, we would surmise that this is a hyperbola. And that's because we have a positive minus something. We've got different signs, plus and minus. Now, order matters. And looking at this at a glance, we would say, well, it's probably a vertical ellipse. However, I'm going to end up with a number over here on the right. And if that number is negative and I divide by a negative, that would reverse the order of these two terms. So we can't assume the orientation until we get it into standard form. And standard form is going to have each of those squared terms equal to 1. So let's complete the square twice and put this into standard form. So organizing and grouping my y and x terms, I now have a negative 28 over here on the right. So again, can't assume that this is going to be y squared minus x squared just yet. First thing I'm going to do is factor out a GCF. If this leading coefficient is any number other than positive 1, we factor out a GCF. So I'm going to factor out 4. That leaves me with y squared plus 6y plus some value. And on my x squared, again, I must factor out a GCF. This coefficient is negative 1. I'm going to factor out a negative 1. That leaves me with x squared minus 4x plus some number. Again, that's going to equal negative 28. And whatever number I add to the left, I will also be adding on the right. So I'm going to add 4 of something and then minus 1 of something. So determining which number goes into each of these spaces, we say b divided by 2 quantity squared. Doing so, I have 4 times y squared plus 6y plus 9 minus 1 times x squared minus 4x plus 4, and that equals negative 28 plus 4 times 9 minus 1 times 4. Simplifying, I have 4. That's going to become y plus 3 squared. I have minus x minus 2 quantity squared. And the number on the right turns out to be positive 4. Putting this into standard form, I'm going to have y plus 3 squared minus x minus 2 squared. That will be over 4 equals 1. So if I divide this by 4, I've got 1/4. 4 divided by 4 gives me a 1. So notice there's a little invisible 1 in that denominator. Here now, I'll go one extra step. I have y plus 3 squared over 1 squared minus x minus 2 squared over 2 squared. That's equal to 1. I encourage you to go that extra step and find the roots of each of those denominator values because that's just going to help you to not make any mistakes. So now that we are this far through the problem, we know that this is a vertical hyperbola. That means it has a vertical transverse axis, and it means it opens either up or down. I should say up and down. Okay, so we've got a vertical hyperbola. Remember, my A value comes first. So A is 1, and my B value comes second. B is 2. Now, hyperbolas are different than ellipses. Ellipses, the A value must be the bigger of the two. But with a hyperbola, the order matters. So A is first, 1. B is second, 2. And in this situation, B is larger than A. They can even be equal, as I've said before. My center, HK, my center is at positive 2, that is positive 2 associated with my X, and negative 3. Remember, our standard form has minuses in it. That means we're pulling those opposite values out. So we have our center, and then the C value, C squared equals A squared plus B squared. C squared equals 1 squared plus 2 squared. We're going to get that C equals the square root of 5. Let's list our attributes. We have a vertical hyperbola with a center at 2, -3. So my vertices are going to be moving up and down from this value. That means it's a change in y, and I use A. A is always the value I use for my change in y. So this is going to be 2, -3. Minus 1 is -4, and 2, -3 plus 1 is -2. My foci, I'm adding and subtracting a C value. That's going to be 2, -3 plus the square root of 5, and 2, -3 minus the square root of 5. We have one last piece for us to write, and that would be our asymptotes. So we like to think about this as a point slope form, or y minus k equals plus or minus whatever my slope is, x minus h. So we're going to have y minus, my k value is -3, so that's going to become plus 3 minus -3 equals plus or minus some slope, and we have x minus 2. So how do I determine my slope? Remember, slope is rise over run, or change in y over change in x. Which value is under y and which value is under x? We've got 1 under y, 2 under x. My slope is going to be 1/2. In this situation, it's a over b. So these are two lines, and you can put them into your standard y equals mxb form if you need to. You just distribute and add the term. That should be pretty easy for us to do. And I've listed those after I've simplified these two equations into y equals mx plus b form. Let's look at creating the graph. My center here is at positive 2, -3. Now the center is not really a point on the graph, so I'm going to draw that in light gray. Now because this is vertical, my vertices are going to move up that A value. We're going to move up 1 unit above and 1 unit below that center. So I'm plotting my two vertices, and then my foci are moving an approximate value up and or down off that center. Square root of 5 is roughly 2.2, so I'm going to shift this up 2.2 units and 2.2 units down in order to plot those. So 2.2 might be around here and around there. So now my vertices, those are my really important pieces that my graph is going to pass through. And in order for me to finish sketching this, I'm going to use my B value, which was 2, to help me draw my little square. So that means I'm going to shift 2 left and 2 right. Oops, that's not 2. 2 left and 2 right. This gives me a rectangle. Now this rectangle, again, is not part of my graph, but you'll notice the slope through the rectangle is up 1 over 2. 1 over 2, positive 1/2 and negative 1/2. Sketching my asymptotes, I'm going to draw them right through here. I've got one asymptote and my other asymptote looks like this. And now I can graph my hyperbola. So my hyperbola bounds up to my asymptotes. It's symmetric in an ideal, perfect world. And it's opening up and down because we have this vertical transverse axis which passes through both of these. So that's how we can deal with hyperbolas and graph them and list all of their attributes when they are not oriented or centered at the origin. In this case, the center was shifted off of the origin HK units, or 2, -3. 2, -3. As always, send me email, comments, questions, concerns. I'm here to help. Good luck out there.